In this video, we're going to talk about types of discontinuities. We're going to talk about three types: jump, removable, and infinite. Okay, so let's start off with jump. What is a jump discontinuity? Well, like the name implies, there has to be a jump in the graph. How do we say that in mathematical terms? We say the left and right limits at some point x equals a. They exist, but they're not equal. So what's an example of a graph like this? You might be able to think of one. There's a nice easy one that we can always think of. It looks like this. So this is defined to be 1 for x greater than or equal to 0, and -1 for x less than 0. So let's look at the left and right limits at x equals 0. The limit as x approaches 0 from the left of f of x. What's that equal to? That's -1. And the limit as x approaches 0 from the right of f of x. That's equal to +1. So these both exist, but they're not equal to each other. That means that the graph has to jump, right? And when we talked about drawing the graph without picking up our pencil, this function fails that test. This is a jump discontinuity. All right, the next one we'll talk about is removable. So a removable discontinuity, if you could redefine the function's value at the point in question where there is a discontinuity, and if you did that it would be continuous, then you have a removable discontinuity. So that's a lot of words, but it's simple to see in a picture. So let's think about this graph. Okay, so this is going to be something like x cubed, but then at the point x equals 1, f of x is defined to be 0. Okay? So now let's think about what a removable discontinuity is. If we could redefine the function's value at the point in question, which would be 1, to make the function continuous, then we have a removable discontinuity. So how could we redefine this? Well, we could just redefine it to be the normal x cubed function, right? We could simply move this point up to 1, and then this would be continuous. you could draw this line without picking up your pencil. Okay? These jump discontinuities are not removable discontinuities. There's no way to redefine the value f of x at 0 to make this continuous. You would always have to jump somehow. If you redefined this to be -1, you came in from the left, it'd be filled in here, but then you'd have to jump up to continue graphing. In some senses, removable discontinuities are a little nicer than jump discontinuities. Okay? So again, this is a removable discontinuity. And this graph here is continuous. Okay? And the last one, infinite discontinuity. So like the name implies, an infinite discontinuity has some sort of relationship to something going to infinity. We've looked at the limit, various limits of 1 over x, right? Graph of f of x equals 1 over x. This graph has infinite discontinuity, right? A function has an infinite discontinuity at a point if it has a vertical asymptote at that point. So the point x equals 0 here, we do have a vertical asymptote. So these are easy to see graphically and visually. All you have to check is if you have a vertical asymptote. Okay, so those are 3 types of discontinuities.